All right, welcome to part 3 of this 9 chassis repair-a-thon for the guys up at the Game Gallery in Pennsylvania. These were 2 of, I think there were 3 chassis that were wrapped up that were unmarked as to what they came out of, or if they went into something or condition or whatever. There were 6 of them were marked as to what games they came out of, and I think 3 of them were not marked at all. These are 2 of the 3 that weren't marked at all. And there were also 2 of the 3 or 4 that were absolutely filthy. So I did wash these last night from my perspective. Can't say from your perspective, but I let them sit out. I dried them off with the compressed air, let them sit out overnight, so they're okay to work on now. But this one here, I think this one was so freaking dirty that I actually had to clean it before I did anything to it. I didn't even want to touch it, it was so filthy. But anyway, we have a 25-inch K7000 and a 19-inch medium res K7000. So we're going to start with the medium res 7000, and just like the part 2, the previous video in the list here, we're going to do 2 7000s, and we're going to go through everything on one, and then we're going to duplicate everything we went through on this one, and if there's any anomalies, we'll show it. If not, I'll do all of the testing and everything, rework and whatnot off camera, and we'll test it at the end. So just kind of avoid having to have another hour and a half long video for these. So if we just give this one a good look over, it is complete, but it looks like it's completely original. No one's messed with it, no one's touched it, no one's done any rework, things like that. Now, how can you tell this is a 19-inch medium res? Well, this has the 25-inch B+ resistor. If we look at the 25-inch one, well, it's a bit different, but the larger resistor is the 25-inch. And if we look actually at this one, you can see P538 right there. That's a dead giveaway that it's 25-inch. However, this one has the larger 25-inch B+ resistor, but if you look, it says P447. That is 19-inch. But if we look here, not only does it have the larger resistor on a P447, that's their first dead giveaway, it's medium res. The second is that there's an extra little axial cap here. There's a little silver axial cap. That's not on a standard res chassis, so that's dead giveaway number 2. And dead giveaway number 3 is, if you look at the back, there are these bodge wires from the factory. There's 3 bodge wires here that are from the factory. Usually some of them just have these 2 over here, but this one has this third one, and there's a factory resistor across here also. That's factory. So there is this jumper from one leg of the C38 width cap to C37 and D15. There's also a jumper from the other side of C38 off to ground. And then this jumper over here must be something for the, it's grounding, I'm not sure what it's grounding, R96. No, that's over here. I'm not sure what this one does. It doesn't really matter, but there's 3 of these jumpers here from the factory, and then we have the little axial cap and the larger resistor on the P447 board. Dead giveaway, all those indications. This is a medium res 19-inch 7000. They never made a medium res 25-inch 7000, so don't have to worry about confusing it with 25-inch. Anyway, all the pots are in good shape. We went through all these and looked over these before in the first video where we unboxed everything. All the pots are in good shape. None of them are broken. Same thing with the neckboard pots. And while we have the neckboard pots on our mind, let's go ahead and put them all to center for our good baseline. All right. And everything on the neckboard looks like it's intact. There's not really any damage or rework. This has not been touched as far as I can tell. This is all original and factory. But like all of them, R101 here is in abysmal shape for that solder joint, but we're not going to worry too much about that right now. So the one thing I do want to point out is that this Flyback has a massive crack across it. And I had mentioned in the first video where we went through these that it looked like it had some type of white discoloration where it was arcing. But again, the face of this is not subject to the high voltage. The high voltage ends kind of right there. So this faceplate here, all of this faceplate is not really subject to the high voltage. Behind this faceplate is some more of that potting material that separates the high voltage section from the faceplate here. So you can have leaking high voltage out of these cracks and out of the faceplate, but only if that potting material back there is bad or has developed an opening unto itself. Now take that with a grain of salt because I'm not an expert. If someone else down there in the comments want to put your comment, if you know more about it, feel free. But I'm 99% sure that if we crack this apart here, the backside of this has just got a potting in there that protects all this, because you have to seal these pots. I mean, the pots aren't sealed around here so you can turn them. So that would, you know, insinuate that this area here is not subject to the high voltage. Otherwise, they would need to permanently seal around here, or the high voltage would just leak out through these pots, and it doesn't. So if you have a massive crack across the front of your flyback like this, it doesn't necessarily mean that it has to be changed. Only if it's leaking or arcing or has residual high voltage leaking out of all this, only then would you really need to change it. So we're going to leave this on here, and as long as it's not arcing, leaking, or zapping, or whatever, I mean, if we take our screwdriver to adjust this and we hear a hissing sound, if all that's okay, then we're not going to change it, because there's no guarantee the replacement is going to be any good. Like I've mentioned before, it might last 5 minutes, 5 hours, 5 days, 5 years, you never know. So it's a gamble with the new ones. So unless this is actually leaking high voltage, if it's functioning with good high voltage and good focus, we are not going to replace this. That's my recommendation on the Flybacks, whether it's white knob or black knob, doesn't matter. Now when it comes to completeness, like I say, everything here is original, but we're going to go through first and just do our voltage testing and all of our other stuff and make sure nothing is bad, and then we'll go from there. So as always, as a refresher, if you're stumbling upon this in the future or independently of the playlist or whatever, if you haven't seen any of the other, if this is the first 7000 video I have that you're stumbling across, let's go ahead and just do a refresher so everybody understands and knows what's going on here. So, all right, so this is completely unknown. I have no idea if it works. I have no idea the condition, no idea what's going on with it. I do notice here the H center jumper is on the right. It should be in the middle for center, and R89 is not in circuit. And I'm worried about this because I might not be able to get this off of here without breaking the wire or the pin. We got it. Okay. Man, that was tough. All right, we'll leave that on the center position. Okay. Now, back to what we're doing here. So we'll start with R103. I'm going to go through here and show you everything to test in your power circuit. I guess we'll go ahead and actually start with the fuse. Fuse is 0.4, so that's good. And we'll start with R103. It should be 3 ohms. This guy right there. And this is all stuff we're going to test that will keep this from turning on and or blowing the fuse. But the fuse is okay, so everything should be okay. We'll test anyway. So R103 should be 3 ohms. Actually, it's supposed to be 2.7 ohms, but 2.9 is fine. Now let's go to diode mode and check our rectifier diodes. 19 is good. 20 is good. You're looking for a 0.5 voltage drop, give or take. 21 is good. 22 is good. 24 is good. 23 is good. So those are all right. Back to ohms. R104 should be 15 ohms. 15.7, good enough. R101 should be about 4.8 or higher. 4.8K. 4.8K or higher. If it's stuck around 4.2, 4.3, then that means our HOT is likely shorted. But if it's 4.8 or higher, then our HOT should be okay. And we're reading 4.7, 4.8, 4.9, so that's good. It's a 6.5 k ohm resistor. Out of circuit, in circuit, it reads through a bunch of stuff. So as long as you're 4.2 or 3 or higher and it climbs, you're good. 4.2 or 3, then you've got a HOT issue. All right, R88 should be 1.8 K. Yep, R96 should be. Not every chassis has R96. If you do, it should be 1.8 K also. And that's not right. That's not right. That's 1K. Well, the resistor that's in here says 1K. I don't recall the medium res using. I've never seen a 7000 in my life in any way, shape, or form ever that used a 1K ohm resistor. An R96. It's either missing completely or it's a 1.8. 1.8K. 1K. I wonder if somebody has replaced that. It doesn't look like it. Well, that should be 1.8K. I'm going to change it to 1.8K because I've never, in all of the 7000s I've worked on, medium res, standard res, doesn't matter, I've never seen a 1K ohm resistor in there. That should be 1.8, so I'm going to change that out. But R89 should be 3.9K. That's this big white ceramic one, and we get 3.85. That's perfect. R97 should be 270 ohms. Yep, perfect, right on the money. Let's test our C38 width cap, which is this guy right there. And that's going to be across here. We're just looking to make sure it's not shorted. We don't care what it reads, but it's probably going to be 130K or something. We're only interested to make sure that it's not shorted. And, well, 3.3K. These are all different. Every time you test it, it's different, but that's fine. D18 is not installed on this chassis. Not every chassis uses a D18. And it normally resides right here in front of the horizontal yoke header pins. And in front of C38 right there. It's not installed, so we don't got to worry about that. We'll check C37, which is in there, along with D15. We're just checking to make sure that that's not shorted. And it's not. 3K, blah, blah, blah. That's all fine. Let's test our HOT diode mode. Negative lead on the top pin, and we should get, with our positive lead to the bottom two pins, should about 0.48-ish, give or take, to each one. 0.477, and the other one, 0.476. Now our critical safety cap is the single cap with 4 legs, that green one in there. And to test that, we put our negative lead on the bottom two here, closest to us, and go caddy corner across. We should get that same 0.47 reading. Yep, and then caddy corner across the other way here on the 4 posts, or 4 points. That's good. So now we'll check our voltage regulator. There's 2 ways to do this. We can go to ohms and check across here. We should get about 180. Some of these have an extra resistor across here. This one doesn't. So about 180 if I'm not mistaken. Yep, 177.5. That pretty much tells us our voltage regulator should be good. But for the tall skinny ones, it's pins 3 and 4. For the fat wide ones, it's pins 1 and 4. So this is going to be a 1 and 4 circumstance or scenario. So we'll go to diode mode. Negative lead on pin 1. I don't know if this is pin 1 or this is pin 1, but the one closest facing this way will negative, and then positive should get about 0.150. Okay, 0.147. So instead of being the 0.48 or 0.5 voltage drop that you normally see through the regulator, through the diode inside of there, we're reading 0.148 because we're going through the resistor here. The 2 leads of the resistor are tied to pins 1 and 4, which is the output. So that is everything that we need to check for our power. Now we do need to kind of rebuild this first before we try to do our light bulb test and all that jazz, but for now it all seems okay. And all these caps are absolutely original. These are the original ELNA caps, E-L-N-A. So, and you can tell because obviously it says ELNA there, plus all the hydroscopic, not hydrophobic, yeah, hydroscopic, all that hydroscopic glue they put on there to keep them in place is all still present on the cap, so no doubt there. So the first thing I want to do here is try and replace this R96 with a 1.8K. It's not going to be that critical if it's not supposed to be 1.8, but I've never seen one that's 1K in 96 ever. I don't understand that, so I don't know of any schematics. If you try and find the schematics for the medium res K7000, I don't think there's any out there. You'll only find the schematics for the standard res 19-inch, and that's either going to have no R96 installed, or if it does, it's going to be 1.8K. And that maybe somebody has replaced this because the pad is loose. I'm wondering if someone has replaced that, because that's not one that normally is supposed to be in there. Oh, here we go. All right, well, and it says 1K on it, so I need to find a replacement R96. Do I have one here? Nope. I know I'll have one on this Zenith, so yeah, R96. Have already stolen it. It's down in there and I've already stolen it. So we've had issues like this in the past, it looks like. Alright, let me find one and I'll come right back. Okay, I found one here on this very derelict 7000. Right here. I need to add this to my list of stuff that I keep a running tab of stuff I need to work or order, I should say. So here it is, and if we test it, it should be 1.8K. Boom, 1.8K. Alrighty, so let's get this in there. I'm confident about putting this in there as opposed to that 1K. I'm not sure how that happened or who put that in there or where it came from, but that's not what should be in there based off my experience. Caveat, asterisk, based on my experience. Now, like I say, we could try to look it up, but you won't find schematics or diagrams or drawings for a 19-inch, or I'm sorry, a medium res 19-inch. Not that I've ever seen or aware of. If you're aware of dedicated schematics for the medium res 19-inch, make a comment and let me know. But all right, let's make sure that reads continuity here. Yep, and yep, okay. All right, well, so that's taken care of. So I guess what we can do now is repair. We need to repair the pads for R89 and R105. Doesn't need reflow now, neither does R104. Let's repair the pads and traces for R89 and R101 like we normally always do, and then we'll go ahead and do our light bulb test and verify our power supply section is good. And if so, then I'll go ahead and do the full cap kit, the full reflow, and everything else we would normally do to this. Then we'll go ahead and test it, but not before we do all that same rework to the other one, so we can test them back to back. And so everything actually tested okay in our power circuit to let us at least power it up. But we do need to do the normal rework for R101 and R89 because R89 is just sitting there flopping back and forth, and that's this guy here. And you'll see here if I move this around, right there, that's no good, and right here, that's no good. It's not even, this whole pad's moving. I don't even think the pad's connected, and down here, it's not even soldered in. If you look right here, I can just hello, move it up and down. So we got a pad problem here and a solder joint problem here. So we're just going to remove it completely. Oh yeah, that's oxidation. That whole joint came off the pad because of oxidation. Wow, okay. Now let's take R101 out of here. This whole pad's oxidized beyond belief also. Let's take this one out of here. So R101 and R89 like to run very hot because they're part of the two main resistors in the power circuit. And if we just look at how bad this is, this should be nice and shiny. And it is dull and gray. Let's get rid of some of this bad solder too. Yeah, the only place on here that solder even sticks to is this tiny little part right there. Everything else is just bad. Now we can take our little fiberglass scratch pin here that I use that has actual fiberglass that they use for scratching up cars for paint purposes, and we can just kind of miraculize this here. That's what it should look like. And let me desolder this other leg for R101. Actually, see, when I desolder that, it's nice and shiny. It's not dull and gray. So that just that R89 joint was bad. Do the same thing for this one over here. It should end up being shiny after we're done. Yep, okay, so oxidation didn't do too bad of a job for those, but we're still gonna clean them up. So now I need to brush all this fiberglass off into my trash can because we don't want to get it on our hands. It's not fun. Get those bristles stuck in your fingertips. All right. So now we're good to go. Let's go ahead and desolder this too. All right, that's good. When you remove the old solder, if the joint is still shiny, you're good. If it's not, or if the solder just pops right off and it wasn't stuck down at all, then you're not in good shape. Now, before we actually put this stuff back together, we need to clean off the tips of our R101 so our solder has something to stick to. We're going to get rid of all of our oxidation off of our leg on both sides of this. And when you're done, it should look something like this. There you go, see that? That's what you're wanting on these, so the solder has a nice place to adhere to. So now we can get this back in here. Well, actually I need to get rid of some of this that's on here. Okay, now let's try this again. This is something that's mandatory on every 7000 you work on. If you got a 7000 you're trying to repair, rebuild, whatever, this R101 and R89 rework is absolutely mandatory on every one of them. Don't overlook it, because this is one of the most important preventive maintenance things you can do on the 7000. Alright, now let's get this back in here. And let's make sure it sits flat on the board when we tack this in. Okay, now zoom in a bit. And let's hit this one. And I always like to do a little solder bridge over to that next pad there for strength and connectivity thing there. Sometimes you gotta get the right angle so this solder flows. There we go. So I do that for one end. The other end I do the same thing, but only over to R101. There we go. That is not bad at all. Now we can hit R101 here. And what I'll do is I like to create a bridge across here, just like so. Bam. That helps for security, strength, and to pass some of that extra heat through. So that's what I do for R89 and then R101, of course. And then over here we can do something very similar. There we go. Ladies and gentlemen, it works just like that. You don't, they say flux is your friend. People add flux to do all that stuff, but if you have the nice solder with flux in it, the solder has flux in it already. There's not really any reason to add more flux unless you want to. You can never have enough flux. Let me just say that. But you saw I didn't use any flux there at all, and it just kind of flowed right to where I wanted it. So I run my iron at 800 degrees Fahrenheit. This is the solder that I use. It's a 6337. So that's what I use, and it worked just great. So with that complete, I'm going to look this over and look for any Other anomalies like flyback pins that need reflow, nope. Our horizontal width coil is good. Not that we're going to use that when we power it up for our light bulb test, but okay. All that looks okay. Now, I can't stress enough also on the medium res, because they like to run hotter, that you really want to make sure your solder joints are really good on your horizontal width coil, or they will just burn up on you. So these all look pretty good, but I'm still going to go through here and reflow all these. Man, these are a little oxidized, as expected, because of the heat that comes off of this. So a little scrape with the soldering iron tip, and they'll come right back. Alright, good enough. No, that one here is no good. A little too much solder on that one. Alright, and I don't think that's the same trace, so let's get rid of... Is that the same trace? It might be. Yeah, I think it is. Alright. We will, yeah, because one leg is... There's only two legs on this coil, and I think it's... Let's get rid of this solder ball here. I think it's these two run to here, and that's one, yeah, see, that's 1 ohm. I realize you can't see, but so the coil itself is across here, see, 0 ohms, but we're going to have continuity to here, 0.3, 0. Yeah, it's going to be the same because of the coil. However, there shouldn't be continuity between... I need to look at one that's removed here. That one's too... That one has the... Some of these 7000s have the provision for the 2 different sizes of coils. This one only has size for one size. And see, this one has the provisions for 2 sizes. So you have the one that's around the very far outside. See, those 2 holes aren't even used, but on this one they are used or something. So yeah, but it looks like, okay, so this island here is separated from the rest. So those 2 right there should not have continuity across these. So I just want to make sure that I don't have this bridge when I shouldn't. So I think there's so much flux here. Okay, yeah, we're good. So all 4 of these have continuity, and then this one is separate from the rest, so that's fine. Okay. Yeah, and as I look at this from another angle, we need to kind of clean that up there. All right. So that should be good. Okay, just want to verify all that, because I'd created a bridge across these 2. I just want to verify that that was going to be okay, because I couldn't recall what the pathways were. So as long as all 4 of these are together and separate from this one, that's fine. Now, so it should have like a little bit less of a reading here across these 2, or more of a reading. Yeah, 0.6. Okay, now if we go here to here, yeah, 0.1, 0.0, 0.0, because it's all the same. This comes up here and goes across all 4 of these. And then if we go over here to the other side of the coil and we read through the coil, instead of 0.0, it's 0. What in the world? 0.2, 0.3. I must be going through something else. Okay, well, there's 0.3. Okay, there we go. Man, losing my mind. All right. I got off on a tangent there. Okay, well, let me go ahead and do our light bulb test. If that passes, then we'll do our reflow and our cap kit and all that. And then I'll do everything that you just saw me do to this to the other one. And not barring anything that needs to be shown on the other one that I find, we'll just go ahead and get these ready for testing on the tube. And so how we do the light bulb test is if you're not comfortable doing it this way, you can just remove the HOT completely. But with the horizontal output transistor removed from the circuit, that will prevent our high voltage from energizing. Our flyback won't turn on, or our horizontal output circuit won't turn on, and you can freely do the light bulb test without fear of high voltage energization. So what I do is I just desolder the collector leg of the HOT, which is the output to the circuit, more or less. And we'll make sure that it's not touching the trace. Okay, now if we take our leads and put them in continuity mode, and we do that, and we'll go here to the trace, or the pad, continuity, go to the pin, nothing. Alright, so if you're not comfortable doing it that way, you can just remove the HOT all the way, however you like to do it. So this is a 19-inch chassis. It should be putting out 123 volts for our B+. If we look at the voltage regulator here, you can see it says STR3123. STR3123. That indicates 123 volt right there. And then the STR3130 is 130 for the 25-inch. So if you ever want to know, if you ever think, oh, I might have the wrong voltage regulator installed, just look at those numbers. 123 is for the 19, 130 is for the 25. Now let's grab our negative here. Actually, I don't even need the negative one. We can use our light bulb. All I need is a positive. One side of your light bulb hooks to the blue wire on your B+ resistor. The other side obviously goes to ground. And we're using a 60-watt incandescent bulb because that is almost a perfect analogy to the draw on the circuit that a picture tube would do. So we're going to use a 60-watt incandescent light bulb. We'll connect our ground there, go to volts DC, hook up our positive wire for the meter to the same blue connection, and plug in our power. And if this works, if we don't have bad caps or something, we should get 123 volts and the light bulb should turn on. So let's find out. 1, 2, 3. Indeed, light bulb turns on and we get 122.2, a little bit low, but not out of the realm of normality. Of course, there's some caps that will probably need to be changed, but we have 123-ish volts. Light bulb lights up, nothing's exploded, power supply, good. So I'm going to do a recap, a reflow, a little bit more cleaning, and then I'll set this one aside, and then I'll take this one and do everything to this one that you just saw me do to this one off camera. If anything needs to be addressed, I'll go ahead and cut in and address it. If not, when I come back, I'll have both of these done. We can check them over, or both of these reworked, I should say, and caps, reflow, whatnot, and they'll both be ready for putting on the tube, and then we'll try and do some testing. So I'll get all that done, and should go uneventful, and stay tuned for a few moments. I'll come back, have all this done, we'll see how it is, and pick up from there. Alright, both of these are now complete. Cap kits, reflows, inspection, what have you. Everything is good to go. This is the medium res, and we can take a look and see that it's all nice and clean. And bottom side, same story. Cleaned up all that factory flux. I mean, it's not perfect, but it's 1,000 times better than it was. And we're ready for testing on this. Now this other one, I found no issues. Everything tested fine. Light bulb test, all of our power section stuff, and no problems. So I went ahead and reworked this one. Full cap kit, reflow, cleanup, all the same stuff. And of course this is the 25-inch. And it was not marked. I have no idea of its condition or what it came out of or anything like that. So we could plug it in, it could blow up, but all our tests indicate that it shouldn't. Could have collapsed, I don't know. And I do want to mention that, well, I also had to install my little test spare 7000 remote board that I have, because this one didn't have one originally, and I'm going to send it back without this one because this one's mine. So this is just installed for testing. But one thing on this I did fail to mention in this video, but I mentioned it in the original unwrapping video, the part 1. Somebody has broken the glue off of the shutdown pot and adjusted it. So we're going to have to set up to test and make sure if this does turn on. We're going to have to set up and test and make sure our shutdown pot is adjusted to 9.8 volts DC. And how you do that is on the cathode here of D12, which is right here, the side with the stripe. You connect a multimeter to there and then across to ground. So positive on here and negative on ground. We should get 9.8 volts DC. If we don't, we can adjust this pot as need be. So someone has messed with that, so we'll verify that's good. But otherwise, I think that's about it. So I'm going to start with this medium res 19-inch. I have a test tube we can test this on. I do not have a medium res yoke set up, but you can test a medium res chassis on a standard res yoke for 3, 4, 5 minutes just to make sure it turns on, can adjust, it's not collapsed, colors are good, you know, no hula dance, waviness in the image. You can run a medium res on a standard res yoke for some quick 5-minute testing, but that's about all you really want to gamble on doing that. So we can do that here, and then if that all pans out and works, we'll move on to testing this one on a regular 25-inch tube, which is the U5000 I have for all this testing, and test that one and see how it goes. So let's get this one hooked up onto the tube and turn it on and cross our fingers and see what happens. All right, so we are hooked up to our test tube here, and the chassis is kind of sitting pulled out a little bit here precariously on this magazine because we have to be able to adjust that shutdown pot if need be. And I have, like I say, the red lead on the cathode of D12, and we're going to ground, and then we're measuring volts DC, and everything's connected. We have our anode, neck, yoke, ground, power, video, remote. We're using our Cruising USA board here for a medium res signal, and we're just hoping that this turns on at least, because this does have that giant cracked flyback on the face there that I talked about how, but it should be good because as I mentioned, there's no high voltage coming through there or would leak out around the pots. So you can have cracks in the face of those and have them be good. And just to verify, we're going to go ahead and turn it on. If it works, I'll disconnect the ground from here after we adjust our shutdown, and I'll just kind of hover this around the flyback, make sure there's no voltage leaking out through that way, so before I touch any of those pots. But anyway, enough jibber jabber. Let's turn this on and cross our fingers. 1, 2, 3. And yes, it comes on, and we're at 9.5. Close enough, I guess. And we get a picture. Okay, we're going to have to move our H position way over. But first, let's go ahead and try to adjust that shutdown pot. I turned it off. Let's try and adjust this shutdown pot a little bit from where we're looking at it here, a little bit counterclockwise, just to turn a little bit. Try it again. Here we go. 1, 2, 3. 9. Oh, wrong way. Okay, so turn it clockwise just a little bit. Okay. 1, 2, 3. 9.5 again. All right. Looking for 9.8. Okay, a little bit more. 9.8. Good enough. Close enough. Fine. Okay. Now, let's see if we can adjust this a little bit. Zoom out slightly. And every time I adjust this to get ready, it never works. Because this is a piece of crap tripod. Okay, well can we go with that? Okay, we'll go with that. All right, let's disconnect the negative off of this and hover my little screwdriver here. Oh, you can't see. Around the face of that flyback to make sure there's no voltage leaking out of that crack, and nope, we're good. Okay, now I can touch those focus and screen pots without fear of getting shocked. Okay, so let's start with brightness all the way down, contrast all the way down, screen pot up until we get retrace lines. And we don't get retrace lines. You won't always get retrace lines. Depends on the model of flyback and things like that. So I'm going to take this flyback and turn it all the way down and turn it up to about, I'd say, 30%. Okay? Now we will turn our brightness up till our background is no longer black, which is, you can see the raster here. Turn it back down till it just is black. We're talking about the raster here. We'll go there. Now we'll turn up our contrast. And, well, maybe I need to turn up brightness a little bit more. No. How about our screen pot a little bit more? Okay, that's better, I guess. We'll go with roughly there. Now let's adjust our focus because we're way out. And we may need to change this flyback because that's what the focus maxed out to the clockwise. So right now, that's what the focus completely turned 100% up. If I turn it down to about halfway where it should be, it's not in focus. So I'm probably going to have to change that flyback out after all. Darn it. Well, I'm not going to show that on camera because the video is going to be long enough as it is. We've all seen that before. So I'll change the flyback, get the focus looking good, and make sure everything works, and we'll go there. All right, well, that's a bummer. I'll go ahead and adjust it as best as I can here. Now I'll adjust H position over. That's vertical position, you dingus. And roughly, I guess that's about as good as we get. So the reason it has a little bit of collapse on the sides because this is not the right yoke, obviously. So vertical size will turn down. And that's pretty good. Colors are fairly decent. It's a little bit too green. Let's turn green down slightly. Turn blue up a little bit. And a little red cutoff. Yeah, that's not bad. I will need to change that flyback out, unfortunately. This is the best this is the best that I can get the focus. And unfortunately, it's not that great. But okay, first one's good. So I'm going to turn this off. We'll swap over to our 25-inch and we'll test that one. All right, so here is our 25-inch hooked up to our U5000. We have all of our connections connected. And these should be somewhat close to what they need to be because we did test this with MK2 and X-Men on the previous section, or previous video, I should say. But anyway, all right, so let's see if this one turns on. We'll cross our fingers and see what happens. 1, 2, 3. All right, nice and energetic, nothing exploded. We're using MK2 PCB and nothing. Oh, there we go. Yeah, sometimes I forget this tube is a bit weak. Okay, well, let's see if we can do some kind of magic here with this. Stay there, you. Okay. I need to adjust our 50-60 hertz pot. Let's begin with black level all the way down, contrast all the way down, screen pot up until we get retrace lines. No retrace lines. So yeah, these factory flybacks, I guess, don't like to do the retrace lines. I'm not sure, but again, I'll put it about 30%. Now black level up until the background's not black anymore. Back down till it just goes black, roughly there. Contrast up as required. Nice. Okay, a little bit too bright still, but that's fine. And okay, so now we need to fix that fold over at the bottom. We can do that by simply adjusting our 50-60 hertz pot right by the horizontal position. And just for demonstration purposes, let's go into the menu here. Monitor patterns, that's not what I want. Monitor patterns, crosshatch. All right, so I'm gonna decrease our vertical size. Maybe not, maybe I'll increase it. And this fold over here should go away, and there we go. Now we have our red block. We'll adjust this to roughly there, Each position will move over to equidistant, which is about there. Now let's see if we can adjust our horizontal size. Actually, I'm going to adjust focus a little bit while I'm here, and that's pretty darn good. It was actually kind of good right where it was at. Okay, width tools. Oh, and I did get the flyback replaced on that other 19-inch medium res. I changed the flyback. Focus was dead center in the adjustment. Beautiful focus, so that factory flyback was faulty. The internal focus resistor was bad. So this one is, or that one's now good to go. This one here, let's make sure we can adjust our horizontal size, and oh yeah, go in there. Creep in, and fantastic. Woohoo! Okay. And I think that's not bad at all. Bikini Atoll. Another inside deep cut for you if you know what Bikini Atoll is. Hey, not bad. Oh, it needs a little bit more blue. That's better. Yes, okay. All right. Not too bad. Needs more adjustments, but not too bad. One more. I don't have low punch, so I can't do Kintaro. I can't do the Soul Sucker. I can do, I know what I can do. Oh, come on. There you go. And, you bastard. There we go. Bloom, bloom, bloom. All right. So there we go. We are now 4 for 9. The first 2 were good. Second 2 were good. We'll move on to the next set of 2 here, probably in the next video. So stay tuned for that. And I'm happy that we got at least the first 4 up and running. So I appreciate it. Stay tuned, and we'll see you next time.